example 6. Same numbers except now A is 3. So we've got side C is 4, side A is 3. Here's alpha. So again, the height would be 2, and 3 is bigger than the height. So it's not going to reach straight down, because it would have to be 2 to reach straight down. So since it doesn't reach straight down, we have to go to the side. But here's where this becomes ambiguous, because it can either go to the side there, or it can go there. There's 2 different triangles. I don't know if you remember from whatever class it was that you solved or proved triangles congruent. You cannot use side-side angle or angle side-side to prove triangles congruent, because there's 2 different possible triangles. So this gives us gamma here, or a different possible gamma value right here. So gamma could be this one, or it could be this one, and there are 2 different triangles. Weird, I know. So since A is 3 and that's greater than H, that's how we know this is going to happen. Okay, let's go ahead and just solve using law of sines like we would and just see what happens. So let's do sine of 30 over 3 equals sine of gamma over 4. Cross multiply, so we get sine of gamma equals 4 sine 30 over 3. So then we'll go ahead and solve that out. So that's half, so that would be 2/3. So then to find gamma, we would do the inverse sine of 2/3. Do a calculator for that. What do we get? Did you guys get the 41.81 degrees? That would be this angle right here. Let's go ahead and solve that triangle using that. So for this beta, that would be the entire angle here. How do we find beta if we already know alpha and gamma? Perfect. So 30 plus 41.81. 108.9. Oh, 108.19. Okay, so what's the last thing we have to find? And should we use A and alpha or C and gamma? Doesn't matter. Doesn't matter. So 3 over sine of 30. So B would be 3 sine 108.19 over sine of 30. Which is what? Yeah. Yeah, I'm going to put the 0 just so that I know I rounded it to the nearest hundredth, even though it's a 0. Okay. All right, so it looks like we've solved this triangle and we're done. However, we know better than that because we know there's actually 2 triangles. So we're not done even though we did solve one of the triangles. So side B that we just found is this right here. Okay, so now let's do the second triangle. So there's the first triangle, so it's okay, we're not done yet. Okay, I'm gonna go back and call this gamma 1 and beta 1 and B1. Okay, so those are the ones we just found. Now let's go to the triangle that would be shaped more like this. I should have used my shape drawing tool. Can someone mute yourself if you have the small child? Do you mind for the time being? I appreciate having your input. Okay, let's see. Dooby-dooby-doo. I take more time drawing my pictures than I need to, but I'm hoping it'll help us see what's happening. So I'm attempting to draw this triangle right here. You can see that it's not exactly the same, but you see what I'm talking about? I'm gonna go ahead and label this one. So alpha is exactly the same. C is exactly the same. I need to get off of my shape recognition tool. A is still exactly the same, but now we have a different gamma, a different beta, and a different side B. Adrian, does that make more sense? I'm going to tell you how to get to it in just a second here. Okay, here's the idea behind the second triangle. This is a 3, but this is also a 3 because that side could either go here or it could go here. If we put both triangles in the same picture, then we have an isosceles triangle because this is 3 and that is 3. If this is an isosceles triangle, then that means that this angle would also be 41.81. In a straight line like this called a linear pair adds up to 180. So this angle right here can be found by going 180 minus 41.81. That is how we find our second gamma. Yep. So now that we have our second gamma, actually we don't quite have it. What would it be? 138.19. Now that we have our second gamma, we totally ignore our first set of numbers and we solve our triangle again using our second set of numbers. So we now are going to find B2 by doing 180 minus 30 and 138.19. Yeah, it's going to be a kind of a small angle. 11.81. So then we have to find little b2. So b2 over the sine of beta, which is 11.81, equals 3 over the sine of 30. So little b is 3 times the sine of 11.81 divided by the sine of 30, which is 1.23. There's our second triangle. How do you feel about that?